Hello, welcome to ETABS course. Okay, we are still in the introduction module, and in this part, okay, we are going to be talking about ETABS axis system. Okay, in ETABS we have global axis and local axis. So I'm going to be explaining this in a moment. All right. Now to start with, the global axis, okay, in ETABS, okay, is referred to as the X, Y, Z axis. All right. Now the x-axis always point to the right. All right. Positive to the right. Okay. The y-axis always point positive to upwards. Okay. While the z-axis, also referred to as the out of plane axis, points positive to the top. Okay. All right. While negative bottom. All right. The x-axis is negative to the left. The y-axis is negative down. All right. Now the global axis is always fixed. All right. The global axis is always fixed. It cannot change. All right. Now once we come to the local axis can change. All right. It changes with member orientation. Okay. So once a member orientation changes, the local axis also changes. Now the local axis is both the global and the local axis are represented, okay, by colors, the RGB colors. Okay, the R referring to the x-axis for global, while it refers to 1 for local axis. Okay, the G, the green, okay, refers to the y-axis for the global, while it is 2 for the local. Okay, and the blue refers to the z-axis for the global, while it is 3 for the local. Okay, so the local axis is 1, 2, 3, while the global axis is x, y, z. All right, so the global axis is usually fixed to the origin of the model. Okay, so now let's come to members. The local axis. Okay, the local axis is fixed to each member. All right, so along the length of the member we have the one axis, which is the same thing as the red, okay, axis. All right, is the one axis, so it's along the member. Okay, so for a column, one will be pointing upwards. Okay, while for a beam, one will be pointing along the length of the beam. All right, so 2 is the depth, okay, or the bigger dimension of the member. For a beam, it's going to be the vertical. Okay, all right, so 3 is the width. Okay, for a beam is the width or the smaller dimension. Okay, so for a beam is going to be the width. All right, so now after passing you through all these details, okay, they are very, very important. The local axis is very, very important, okay, in ETABS. Why? Because we use it to interpret our analysis results. Okay, now since axis 1 always points, okay, along the member direction, it will always refer to as the axial force. Okay, so it is called F11. Okay, any force along the member axis, okay, the length of the member, any axial force is referred to as 11. Okay, since we are referring to axis 1. All right, so any member, any force, okay, that is along the depths of a member, okay, is referred to as tutu. Okay, for example, the major shear force is referred to as tutu. So shear force happens along the depth of a member, so it's referred to as F22. All right, so and we also have the minor shear force, okay, which happens in a lateral dimension, okay, to the beam, so along the width. So whenever you see FJ3, it's referring to the minor shear force. All right. Now, when we come to the moment, okay, the major moment, okay, for a beam tends to bend the beam in this shape, all right, which is equivalent to rotation about axis 3. Okay, so whenever you see M33, okay, we are referring to moment, the major moment, okay, because the major moment tends to bend the beam, okay, along the axis 3. All right. So whenever you see M22, that will refer to the minor moment, okay? Because the minor moment tends to make the beam to bend sideward, okay? Which will be along axis 22, okay? This axis 22 to bend the beam sideward along axis 22. Okay, so the minor moment is referred to as M22. All right. While the torsional moment, okay, tends to bend the beam, twist the beam along its length, okay? Tends to attempt to twist the beam along its length. So torsional moments, okay, are usually happen around axis 1. All right. So now let's go to a real structure to see how this works. Okay, this is the origin of our project. You can see now that the global axis, okay, is located at the origin of our project. Okay, this is our x to the right, y up, okay, z to the top, okay, positive. All right, so this is very, very important when applying loads to members in ETABS. Okay, so if you're applying loads to member in ETABS, okay, since the global z is pointing upwards, okay, to apply load that goes in the gravity direction, okay, you have to type minus. All right, if you are using the global axis. Now let's look at the local axis for beams and columns. All right, so this is a beam. The local axis 1, okay, is along the member. All right, the local axis 2 is along the depth, okay, and the local axis 3 is along the width. For a column, okay, the local axis 1, which is red, is in the vertical direction, okay. The local axis 2 is along the major dimension, okay, and the local axis 3 is along the minor direction, okay. The same thing with every other member. All right, so now this is a real model, okay. So the same thing, for column, this is the global coordinate, okay. So this is the local axis now, okay. You can see the red for beam is going in this direction, the red is going in the direction here, the red is going in this direction and this direction. All right, so this is how it will look like in the 3D model. So from here now we want to see how this actually works in reality. So the first thing we are going to do is to go to our ETABS model, okay. So the first thing we will notice here is that this is our origin of our project, okay. So this is the right, this is up, and this is top, okay. So the red is the x, the green is the y, and the blue is the z, okay. So we want to turn on the local axis for the members for the frames. So we go to the display settings, okay. We'll go to object assignments. Under frame assignment, we click on local axis and click on apply and click on OK. So you can see here that, okay, the local axis, okay, for each of the columns points along the x axis 1, okay, points along the column which is the vertical direction, while for the beams the red, which is axis 1, points along the member direction, okay, the green points along the depth, okay, and the blue along the width. So it is consistent, okay, in ETABS. All right, so now let me go back to the display settings, okay. So now I can apply this to all views, okay. So the same thing you can see here. All right, so I will uncheck it, apply, and okay. Now the next thing I would also like us to know, okay, is that we can change the local axis of a member, all right, especially columns. So now let me go back, let me come here, go back to my view options, okay, and turn on the local axis. So you can see that this is 2 and this is 3. All right. So now for this column now, okay, if I select the column, I go to assign frame. Okay, I come here and type and go to local axis. Okay, now if I come here and type 90, all right, and I click on apply, you can see now that the what's it called, the axis 2, which was pointing to the right, is now pointing up. Okay, while the axis 3, which was pointing, which is the blue one, pointing up, is now pointing to the left. So this column had been rotated. Okay, if the column were not a square column, okay, you will discover that the bigger dimension that was facing here before is now turned and is now facing this other direction. All right, that is how to change the local axis of a member. All right, so I'll click on OK. Now the next thing I would also like us to consider, okay, let's say we run an analysis. All right, to view our analysis result, you will now see how important, okay, this local, okay, and global axis are. All right, so I can close. Okay, all right, I'll just close and I'll come here. Show undeformed shape. All right, so I'll go to my analysis results. So you can see now this is axial force. This axial force refers to, okay, the force along each of the members, okay, along each of the members. While shear 2 refers to the major shear force. All right, shear 2 refers to the major shear force since it is acting along the depth of the member, okay, and the depth of the member, okay, is axis 2, okay. So shear 2 refers to the major shear force, while shear 3 is acting, okay, along the width of the member, okay. So, and the width of the member is axis 3. Now, as I've told you earlier, moment 3 okay, tends to bend the beam in such a way that it rotates along the major moment, okay, tends to bend the beam in such a way that it will rotate along the axis 3. Okay, so moment 3 refers to the major moment, while moment 2 refers to the minor moment. And moment 1 refers to torsion. Okay, so you can easily close it. All right, so with this now I've covered global and local axis, okay, how to display them. Okay, coming here to display the global and local axis. Okay, all right, so I also covered, okay, how to change it. Okay, just select the member, go to assigned frame, local axis. You can change the local axis by rotating it by 90 degrees. All right, and I also show you how it applies to the analysis result. So with this, we'll come to the end of this part.